Yes, sir, you can start with the session.
Yeah.
Yeah.
Archana Sundar, have we done a PCA? Okay, I think we should do the TSNE. PCA, I think we have already done. Have we done PCA? All right, let's do TSNE today. Algorithm TSNE. Okay. So what is the meaning of TSNE? So the meaning of TSNE is T distributed stochastic neighbor and co embedding. We'll come to this graph. First of all, let's study what is actually it is. So we can see the TSNE the TSNE distributed stochastic need to see sir, we need to see PCA. PCA we have not done. Nikhil, have you done PCA? No, okay. This is what I was asking. Okay, let's do the PCA then. Principal component analysis. Explained in simple terms, principal component analysis is a dimensionality reduction technique. So like it reduces the dimension like 3D to 2D and 4D to 2D. It will convert anything into two-dimensional, or you can say one-dimensional. Used in data science and machine learning to simplify large data sets by reducing the number of features while retaining most of the important information. PCA transforms the data into a new coordinate system where the greatest variance by any projection of the data comes to lie on the first coordinate, called the first principal component. The second greatest variance on the second coordinate, and so on. Why use PCA? Okay, so why we should use PCA? Okay, so it is basically for high dimensional data, like when working with data set that have a large number of features. Feature could be any numbers like 10, 20, 50, right? Some people discuss that we have also some other data where we have thousands of features, means thousands of columns, dimensions. It can be difficult to visualize and analyze the data. Yeah, like you cannot analyze or visualize the data which is like a very high dimensions, right? Like for example, it is having suppose anything about 20, 30 features. You cannot visualize it in a 2D plane. The PC helps to reduce the number of dimensions while keeping the most important part of keep the quality. Noise reduction. By focusing on the most significant feature, PCA can help remove noise. And irrelevant information from the data. Even in your zoom setting, if you see there is a noise reduction facility. Please everybody check it and tell me, do we have noise cancellation in the zoom? Yeah, everybody check it. Do we have noise reduction feature in the Zoom? Noise removal, background noise removal. Yes, we have it. So you can say that these kind of features are made using the PCA. Okay, these kind of features is developed using PCA. We have the noise removal in many of the headphones. Yeah, but noise removal is different thing, reduction is different thing. The things which are done using software, that is PCA does, not the hardware. I think in most of the headphone, it is done by the hardwares. Like they use cushions, heavy cushions around the headphones to remove the noise. Yeah, these kind of things are hardware, so it is not PCA. Okay, so it is having improved performance. Reducing the number of dimension can speed up machine learning algorithm and reduce the risk of overfitting. Yes, what is overfitting and what kind of issue we face when your data is overfitted? What is overfitting? Please write in the chat. An algorithm fits very close to the actual parameter. No, no, not algorithm, but overfitting is like when your which looks fitted, but when we found in some, it's not accurate. No, no, the overfitting is like when your prediction line is tightly sticking with the testing data, sorry, training data. You train a model and you trained a model and your that model is performing very good on the training data. That is the overfitting, and it will not work very good with the testing data. That is called overfitting. You can write overfitting. This one. The last one is the this overfitting. and due to this we face high variance. High deviation in the output. Okay. How PCA works? So how does it work? So it standardize the data. Like since PCA affected by the scale of the variable, the first step is to standardize the data. Okay, we'll come to this later, but one thing I need to show. Yes, this one. You can assume this as a PCA, where all of your this blue one is the your actual data. Okay, and you can see your data was showing a relationship here with the height parameter and the weight. As the height increases, the weight was also increasing. So you can see a line over here. So we'll make a PCA, principal component line, across this data. And all the data will be projecting over this line. So you can see that it was two-dimensional. And after projecting into a single line, it become one-dimensional. This is PCA. Yes, you can see here. Most of the variance across this axis is captured by PCA1, and if there is some deviation on this axis, then it is captured by PC2, right? So all data will fall here. So how does it work basically? Okay, one more thing I need to show you, this one. See, after picking all the data from the graph, we are just using only PCA1 and PCA2 as axis. All right. So standardize the data. So since PCA is affected by the scale of the variables, scale of the variable means the first step is to standardize the data. So ensuring that each feature has a mean of 0 and a standard deviation of 1. So can anybody tell me how to standardize the data? Yes, right. Standard scalar. Min max scalar, lot of things we have. Correct. Okay. Second is compute the covariance matrix. The covariance matrix measures how much dimension vary. How much dimensions vary from the mean with respect to each other. This helps identify the relationship between different features. Covariance matrix. So covariance matrix, like you can say that if there is, you can say 3, 4. Let's suppose we have 1, 2, 3, 4 features. 1, 2, 3, 4. So we will see the relationship of 1 and 2, 1 and 3, and 1 and 4. Then we'll see the relationship of 1, 2, 2, 3, and 2, 4. Just like we will see 1, 3, 2, 3, and also the 3, 4. So all the relation we will see by each and everything. So it will make a matrix.
सर ये अनोवा अनोवा के बारे में आपने नहीं बताया कि ये कैसे वर्क करता है।
अभी कौन सा टॉपिक चल रहा है?
अभी आपका ये
अनोवा कहाँ से बीच में आ गया यहाँ पे?
जी जी
पहले हम
नहीं
जो
वो
कर रहे
मैं
हैं
पढ़
पहले वो
रहा
तो,
था थोड़ा सा।
हाँ वो आप पढ़ रहे थे ना, पहले जो
जी
हम
जी
कर रहे हैं वो कर लें पहले हम लोग.
जी जी
Okay. Um, okay, so it makes the covariance matrix like all the 4 features are given here in the matrix. 1, 2, 3, 4. Okay. So how much 1 is related to 2, 3? So you can, we will just give the numbers here. High number shows the high correlation. It means how high covariance, and low value shows the low relation. So this is how we make the compute the covariance. Like a covariance matrix measure how much the dimension vary from the mean with respect to each other. So suppose if the increase in 1 also increase the values in 3, so it means 1 and 3 are highly related. So it will be 0.9, or you can say 0.8, something like that. This helps identify the relationship between different features. Calculate the eigenvectors and eigenvalues. Eigenvectors and eigenvalues are derived from the covariance matrix. Eigenvector determine the direction, principal component analysis in which the data varies. And eigenvalues determine the magnitude of the variation. So you can see in the graph, if your data is showing us some behavior like this one, which is highly correlation, so you will see that your data is showing a variation among this axis, right? That is called eigenvector. So this vector will be used to make our first PC. This is what it is saying. So in the same direction of this eigenvector, in the same direction of the relation, we make the principal component. And eigenvalues of all this data will tell how long our this line will be, which which is the magnitude of the variation, like how much long this this data will be, that decides the length of the PC. See, eigenvector is in this direction, or eigenvalue decides the height.
हाँ सर, आप प्रिंसिपल कंपोनेंट एनालिसिस की बात कर रहे हैं ना सर, पीसीए की?
Yes, when you have joined,
जी जी जी
you
जी।
just joined to, I think, 3 minutes ago.
जी हाँ सर, वो मेरा लैपटॉप थोड़ा सा दिक्कत कर रहा है सर, मैं इसे रिजॉल्व कर रहा हूँ। हो गया है फिलहाल, मैं आपको देता हूँ इसका कोड।
Okay, so select principal component. Choose the top k eigenvectors that correspond to the largest eigenvalues. Yeah, so these top eigenvectors form a new set of axes, and original data is projected onto these axes, just like this one. Just like we saw earlier.
जी हाँ सर, ये न्यूरो साइंस में भी काम करता है सर।
Like this. See, all the data will be projected on these PCs now. So finally, the original data is transformed, projected onto a new axis, just like this. पहले S1 और S2 थे axis, now it is PCA1 and PC2. ये new axis बन गई इसकी. Onto the new axis, resulting in the lower dimensional representation of data. Okay, imagine you have a data set with three features, like you can say height, height, weight, and age. These features are plotted in a 3D space. PCA might find the most of the variance in the data that can be explained by just two principal components. So if you have a lot of data over here, so we'll try to capture all these data points in a single line like this. And then all the data will be projected on this particular PCA, PC1, our principal component first line, like this. So it projects the data onto a 2D plane that captures the essence of the original data while discarding less important dimensions. Okay, so you can create the one more PCA which is proportional to 90-degree, which is a right angle 90-degree to this previous principal component. Now it is 2. All the data which are now left, you can project over this line. This is how we capture all the data. Okay, let's try the PC on our iris data. So we'll try to compress our data because we have 4 features here in the iris data. Can somebody tell me what are the 4 features in the iris data? Because we have done this data many times. People know how many features we have. Four features we have: sample length, sample width, petal length, petal width. Correct. For standardizing the data, use this: import PCA, import matplotlib, load the data. So before we move forward, let me show you what is X here. See all four features which I talked about. This one. Sepal length, sepal width, petal length, petal width. Okay. Okay, then what we're gonna do? Next thing is we standardize our data with the help of standard scaler. Make object, pass your data, and it will scale it. Okay. After scaling, you will see little bit difference here. See, all the values will be, decreased. See, only the ratios of the numbers are there now. -1, 3, -1, -1 like this. These are standardized now. Okay, next is let's try to make our principal component analysis with the n components 2. So basically it is asking how many PC lines you want to create. We will see 2D, PCA, and then we will write fit transform fit transform. So yes, so you just fit your X, your all these feature, four features we are training our PC on all the four features, right? Okay, after scaling, you will see that we just have two component, two PCA. So let's print that two components. How does it look like? All the four features are now in the two line. Let's see that. See, all the four features are now projected on these two lines.
सर इसमें डेटा कौन सा है?
Huh?
हाँ, इसमें डेटा कौन सा है?
डेटा कौन सा है? कौन सा डेटा है स्टूडेंट्स? व्हाट डू यू थिंक? Write down the chat, student, which data it is. Please write in the like normal. Please write to everyone. It is coming in DM to me. Write to everyone so that everybody can see. to message you or you are the host? We are allowed to message you or the host. Oh, okay. Yeah, so students are already saying it is iris data. Okay, it is iris data by the way. And please be attentive in the session. We have already discussed this. We can only message you, sir. Oh, okay, okay, okay. All right, XPCA. Okay, so X scaled PCA, you have seen everything. Okay, now it's time to make the graph. Okay, but graph we are making for what? First, see, like PLT dot figure. First of all, we are making our canvas 8 by 6, means big graph, and we are making scatter plot. So scatter plot from the PCA, we are taking the first, we're selecting all the rows and first column, and in the y-axis we are selecting all the rows, second column. Two column we had, right? So we are using both. You can see. And the color of the points are according to the target. So we have three targets here: 1, 2, and 0, 1, and 2. It could be any name of the flowers, but it is classified in 0, 1, and 2. Okay, C map is viridis, and size of our points is 100. Okay, so this is x-axis is first component, second component, and this is how we making data. See, lot of variation it captured, right? I can even show you the original data. See, I also made it using the original data, which is after scaling. I use sample length, sample width, and then second plot I'm doing in the same plot, petal length and petal width. You can see easily. Yellow, orange, red. Yellow, orange, and red. These three colors are for the sepal length and sepal width of three flowers. Orange and red. And next is okay. Next is petal length and petal width. Purple, blue, green. So purple is not showing, by the way. Purple, blue, and green. So these are the captured by the petal length and petal width of three flowers. To easily qualify them, like easy classify them. I think we just need chapel length and chapel width, which is, yeah, only because this chapel length and chapel length width, I think, is the most deciding factor to discriminate between the flowers. Rest of the things, I think petal length is not easily describable, but yeah, it is also like easily classified, but still combination of all is required. See, this is how we do. Okay, I'm giving you one data, students. See this. It is having 32 columns, very much. Take this data and try to do PCA over it. The code is here. आप अगर थोड़ी मेहनत करो तो इसमें 32 फीचर्स हैं, ऑलराइट। तो दो दो करके अब यू कैन यूज ऑल द फीचर्स, दो दो करके यू कैन प्लॉट द स्कैटर प्लॉट, बट आई थिंक दो दो करे करोगे भी तो 16 प्लॉट्स करने पड़ेंगे आपको, एंड दैट विल बी टू मैस्ड अप। For PCA, we don't have any easy data set. We need to focus on two variables. Data set for PCA. Let me see if we have some less data. These are very big data, 31 columns are there. Okay. Chronic kidney disease. इसमें भी I think we have a lot. 26, very nice. Wine data set. इसमें भी I think 8, yeah, 40. Penguin species. 5 column. Yes, I think this you can use. The dataset consists of 5 columns: culmen length, culmen depth, flipper length, and body mass. And then penguins sex, the gender. See, why do we this data for? So what is the target variable here? So this is these are some data set. Yeah, okay. So we have to determine the sex over here. Okay. Nikhil gave us this. Let's see. This is data world. All the data for the PCA. Okay, penguin. I'm giving you. You can even try the penguin data. I think this is also will be very easy for you right now. Principal component and wireless spectrum with the data sets. Yeah, these are also very good data. Okay, let's try on the penguin. I think this is very easy. Only 4 columns you have. Very easy. But here it is written clustering penguin species. Yeah, we don't have species here. 1, 2, 3, 4, 5. Total is 5. There is no species column. So sex you have to determine. Okay, let's use this. Code is here with you. This one. It's better that after conversion, after standardizing, not conversion, please after standardize the data and please visualize it first. Make a graph so that you can easily see the clusters of male and female. Okay, I think time is about to end. You can solve this and show me the result in the next session. All right. Whatever result you get. All right. Yes or no? I will see your graph before PCA and after PCA. Both. I want to see the clustering of male and female. All right. Yes or no?
Yes, sir.
Hmm. Okay, fine. All right, students. Have a good day. Bye bye. We'll meet you tomorrow.
सर आपको ये मॉडल आपने कराया
Bye, all of you. Welcome.